Okay, so I'm going to start with number 7, and I'm doing it on a separate sheet of paper, so I just copied the part of the table that we need onto this paper. So we can start by getting the degrees of freedom. Actually, I'll start by saying they want us to find a 95% confidence interval for the slope. So since they're asking for a confidence interval for the slope, these are really the only two values we're going to need. So we find the degrees of freedom first. They give us n equals 22, and since we know the formula for the least squares regression line for the degrees of freedom is n minus 2, we know the degrees of freedom would be 22 minus 2, which is 20. And then we know the slope, which is this, the coefficient. The slope is also our statistic in the formula. It's 1.096. And then the standard deviation, or the standard error, is this value. It's 0.1308. And then our critical value for 95% confidence interval is 2.086, and that's just off the t-table using the degrees of freedom of 20. And then we can just plug all these values into the formula, which is stat plus or minus critical value times standard deviation. So our statistic is the slope, 1.096, plus or minus the critical value, which is 2.086, times standard deviation, which is standard error, 0.1308. And then they don't even want us to solve, they're giving us the multiple choice out of these, and A is the one that matches, so that's our answer. Okay, and then we don't have to list out conditions because they tell us we can assume that all conditions are met, so we don't do conditions. Okay, for number 8, doing it on this paper, I just listed out what they gave us. So they told us standard deviation is 1.5 months. They told us their desired margin of error is 0.1 month, and then the confidence level is 99%, and the z-value for that is 2.576. And we're using z-table because it's a mean. Actually, no, we're using z-table because we can assume that the sample size is greater than 30. Okay, so we can start by setting up our formula. The margin of error is equal to the critical value times the standard deviation, and they want us to solve for n, so we can do that with this formula. So the margin of error they want is 0.1, and we want this value to be greater than or equal to the critical value, 2.576 times the standard deviation. And the formula that we'll use is for the one sample mean, so the standard deviation over the square root of n. So 1.5 over the square root of n. This is the variable we're looking for, so we're just going to solve for that. We'll divide on both sides. And we get 0.1 or 2.576 greater than or equal to 1.5 over square root of n. And then we want to isolate n, so we take it out of the denominator. And then we can divide by this whole fraction on both sides. So this whole thing cancels out, and then the n's cancel out. We're left with n is greater than or equal to 0.1. Oh, whoops, not 0.1. 1.5 times 2.576 all over 0.1, and then this is still under the square root, To get rid of that, we can just square both sides. And then this goes away. We get n is greater than or equal to, if you put this whole thing in the calculator, you get 1493.05. Okay, so that's our value for n. N has to be greater than or equal to that. And the question is asking for the smallest sample size for this margin of error. So we can automatically get rid of these three because those are all smaller than this, and we want it to be greater because this is a greater than. We need our number to be greater than this number. These are all smaller, so we can get rid of them. And then smallest. So this is bigger than this, so we can go with this one. This is the smallest without being lower. Okay. On to the last question. I'll just do it on here. So for this one, they're asking for a 95% confidence interval for the population mean difference in age of maternal grandparents. So this is the difference of population means, and we can just put this in the calculator. So I'll list out all the values, and then we can just plug it into the 2 sample t interval. So they tell us that they sampled 10 high school students. So n equals 10 for both. x1, first value, is our mean one, 69.8. And then the standard deviation 1, it's just the one that goes along with that, 8.38. x2 is 71.6. And then standard deviation 2 is the one that goes along with it, 6.65. And then we plug this whole thing into the calculator with our confidence interval being 95%. You put it into the 2 sample t-test, and it tells you our degrees of freedom, which is 17.12, and then our interval, which is negative 8.934 to 5.3383. Okay, and then we can write our sentence explaining it. So we can say we are 95% confident that the true average difference, just restating the question, of the mean age of high school students, maternal grandmother, and grandfather, can you see that? Is between negative 8.934 and 5.3383 years. Okay, so that's it. And then we can check our conditions now at the end. Probably should have done that first, but we can do it now. Conditions. So they tell us that they use simple random sample, so that's good. T distribution. And then, oh, for the independence, we need n to be less than 10% of the population. So since our sample is 10, if we multiply that by 10, it's 100. So assume population greater than 100, greater than or equal to. Okay, and that's it.